Hello, we're going to look at continuous, discontinuous, and discrete functions today. So just a couple of reminders. A relation is when I pair any input with any output. And then more specifically, we have functions. Functions are relations, but every input has exactly one output. In other words, your inputs or your x values cannot repeat. So a continuous function is going to be a function or a graph with no gaps, jumps, or asymptotes. And on the other hand, a discontinuous function is going to have those holes or those jumps or those asymptotes, those invisible lines. And the last type of function we have is a discrete function. So discrete means individual points. So this looks a lot like a scatter plot. It's just separate disconnected dots on your coordinate plane. So here's just some examples. The top two are continuous functions. Notice I could start at one end and draw the entire function without picking up my pencil. Whereas on my discontinuous, I could draw part of it without picking up my pencil, but then to get to the other part, I would have to pick up. So these are asymptotes. They approach a line but never touch it. Here's a jump. So there's a couple examples. Here is discrete examples. So just a bunch of individual dots. This one seems to have more of a pattern or correlation. With discrete functions, you can find the domain and range, just like you can with a continuous or discontinuous function. But with our domain, we have to say our individual points. So this goes from -5, -4, -3, -2, and so on, all the way up to 6. Likewise, my range also goes from -5 all the way up to 6. But we can't say that it's the entire interval because we don't have a value for -2.5. There's not a dot there, or there's not a dot at 3.5. So our domain and range have to be those individual points, just like our graph is. So if we would be asked to graph a discrete function given the actual points, we would plot those on our coordinate system, but then remember you don't connect the dots because it says it's discrete. We have to keep them as those individual points. Here is a discontinuous graph. It looks pretty continuous except for this hole right here. So this is what we call a point of discontinuity, and you can always find what that point of discontinuity is. And in this graph, it happens to be at 2, 1. You'll also be asked to find what's my domain. Well, in this case, it appears that my domain is all real numbers except for 2. So you can either write that out, all real numbers except x equals 2, or you can say x cannot be 2, and then it's just assumed that it's everything else. So I went ahead and wrote all real numbers except 2. And then to find our range, we have to look at our y values. What are our restrictions? Well, it appears that 1 is our highest y value, so our y has to be less than or equal to 1 for our range. And then one final little note. In order to tell whether these continuous, discontinuous, or discrete graphs are actually functions, the vertical line test will still work. So you can draw those vertical lines in to see if it passes, and that will help you decide whether it's a function or not.